Section 1.5 covers radical equations. So we're going to take a quick look at what these radical equations look like and how to solve them. So the square root function, what it does is it pairs each real number with its principal square root. So it's always going to look kind of like half of a curve or half of a parabola, right? I've got that when x is 0, y is 0, when x is 1, y is 1, and we're graphing the perfect squares. It's important to note that not every number is a perfect square, right? The square roots of irrational numbers are on the plot of the square root of x as well. Its domain, those are all of its x values, is from 0 to positive infinity. Its range, that's all of its y values, is also from 0 to positive infinity. The cube root function is a little bit different, right? Because I can take the cube root of negative numbers, right? The cube root of negative 8 is negative 2. The cube root of negative 1 is negative 1, and so on. So its domain and range are all real numbers. The reason our square root function, that's not the case, is because we cannot take the square root of negative numbers and graph them on the real coordinate plane that we're currently working with. So in order to solve radical expressions, the first thing you're going to want to do is isolate the radical. Then you need to square both sides of the equation to eliminate the square root. You may have to do this twice. Then you want to solve your resulting equation and check all proposed solutions in your original equation. Okay, so let's go ahead and take 3x plus 4 equals 8. I'm going to go ahead and square both sides. I get that 3x, because square roots undo squares, 3x plus 4 equals 64. Subtract 4 from both sides, and I see that 3x equals 60, so x equals 20 is the solution I found. I need to check this solution. So I'm going to take the square root of 3 times 20 plus 4, that's equal 8. That gives me the square root of 60 plus 4 is 8, and we can see that the square root of 64 is indeed 8. This is a true statement. So x equals 20 is our solution. If I have the square root of 5x minus 1, I'm going to go ahead and add 3 to subtract 3 from both sides to isolate. I get the square root of 5x minus 1 equals negative 3. And then I need to go ahead and square both sides. So I get that 5x minus 1 equals a positive 9. I add 1 to both sides. I get that 5x equals 10. This is going to simplify to x equals 2. So I need to check this proposed solution in my equation. I have that the square root of 5 times 2 minus 1 plus 3 equals 0. So I've got the square root of 10 minus 1 plus 3 equals 0. Well, I get the square root of 9 plus 3 equals 0. That gives us 3 plus 3 equals 0, which is 6 equals 0. So this is false. So that means x equals 2 is not a solution. And my solution is that there's no solutions or the empty set. For this next example, I'm going to go ahead and make sure my radical is isolated, which it is. I'm going to go ahead and square both sides. That gives me 4 minus x, because square roots cancel radicals, times x squared plus 4x plus 2, if we FOILed this out. Now I go ahead and combine like terms. I add x to both sides. I subtract 4 from both sides. I get 0 equals x squared plus 5x minus 2. And then I need to find the factors of this should be plus 4. So that way when I subtract 4 from both sides, I get x squared plus 5 equals 0. So I'm going to go ahead and pull out a factor of x. That means 0 equals x times x plus 5. And I set each of these equal to 0. I have x equals 0, or I have x plus 5 equals 0, so x equals negative 5. Now I need to check both of these back into my original equation to see which is the true statement. So I have the square root of 4 minus 0 equals 0 plus 2. That means the square root of 4 equals 2, so 2 equals 2. Awesome, that's true. So x equals 0 is a solution. But let's go ahead and check x equals negative 5. That means the square root of 4 minus a negative 5 equals negative 5 plus 2. The square root of 9 equals negative 3. Well, 3 doesn't equal negative 3, right? When we're taking the square root without a negative symbol in front, we always take the principal square root. So x equals negative 5 is not a solution. We call this an extraneous solution. Gosh, I hope I have room for this one. Let's switch to green. I'm going to go ahead and make sure my radical is isolated, which it is. I'm going to go ahead and square both sides. I have x squared minus 4x plus 9 equals x squared minus 2x plus 1. I'm going to go ahead and combine like terms. So I subtract x squared from both sides. I add 2x. Then I subtract 9 from both sides. So that's going to give me a negative 2x equals negative 8. So x equals 4. I substitute 4 in. That's going to be the square root of 4 squared minus 4 times 4 plus 9 equals 4 minus 1. So I've got 3 on this side. This gives me the square root of 16 minus 16 plus 9. That's the square root of 9. Square root of 9 is 3, so I get 3 equals 3. This is true. So my solution is x equals 3. Or we could write that in solution set notation. My solution set is just the number 3. There may come a time when you need to use our steps for solving a radical equation twice. So let me go ahead and show you how that works. The first thing I'm going to do is isolate one of my radicals. I'm going to go ahead and subtract the square root of 3x plus 4 from both sides. That gives me the square root of 5x plus 6 equals 2 minus the square root of 3x plus 4. I'm going to go ahead and square both sides. The square will cancel out the square root, so I have 4x plus 6. But on the right-hand side, I'm going to have to FOIL. So I'll get 4 minus 2 square root of minus 4 square root of 3x plus 4 plus 3x plus 4 when I FOIL this out. That's what I did here. We used FOIL. That stands for first, outer, inner, last, and that's how we multiply binomials. So now I'm going to go ahead and combine like terms. I have 5x plus 6 equals 8 minus 4 square root of 3x plus 4 plus 3x. And then I can go ahead and subtract 3x from both sides and 8 from both sides. So I have 2x minus 2 equals negative 4 square root of 3x plus 4. I see that all of these have a factor of 2, so I'm going to go ahead and divide both sides by 2. That gives me x minus 1 equals negative 2 square root of 3x plus 4. Now what I need to do is I need to go ahead and square both sides of the equation again in order to cancel out this radical. that's going to give me x squared minus 2x plus 1 is equal to 4 times 3x plus 4. So I have x squared minus 2x plus 1 equals 12x plus 16. I now want to set this equal to 0, right? So I can factor my quadratic equation. So I have x squared minus 14x minus 15 equals 0, and we have to factor this. So I'm thinking, okay, what are some factors of negative 15 that add up to negative 14? Well, that's going to be x is 1 and x is negative 15. Not x is 1 and x is negative 15. My two factors are going to be 1 and negative 15. So I set each of these equal to 0, and I solve x equals negative 1, x equals positive 15. Am I done? No. One of these is going to be an extraneous solution. So I'm going to have to go ahead and plug it into my equation in order to solve. So let me go ahead and, clear some room. We're going to do this in orange. We're going to go ahead and clear room over here. Oop. All right. So I'm going to go ahead and say I'm going to substitute in negative 1 for x. So I have the square root of 5 times negative 1 plus 6 plus the square root of 3 times negative 1 plus 4 equals 2. That means I have the square root of 1 plus the square root of 1 is 2. So 2 equals 2. Awesome. This is a solution. Now let's go ahead and check x equals 15. If I have the square root of 5 times 15 plus 6 plus the square root of 3 times 15 plus 4 equals 2, I get the square root of 81 plus the square root of 49 equals 2. So I get 9 plus 7 equals 2, which is 16 equals 2, which is not true. So x equals 15 is an extraneous solution.